Hello everyone, this is Jaron from MarineAndReef.com. Today we're going to do a video about water testing. We're going to help you guys find out how to make sure your water tests are both precise and accurate. We're going to tell you what those two different descriptors mean, as well as show you some of the tools that help us having good water tests. So first off, we want our tests to be both precise and accurate, but those aren't the same thing and they mean different things. So let's talk about what they are and why we want them. So first off, the whole reason we want to test in the first place is because really having a good aquarium is not about maintaining fish, it's about maintaining good water. If we have good, clean water with the right elements in it, our fish, plants, corals, invertebrates, other organisms will do well. And if that water quality is poor, they're going to do poorly. But without doing water tests, we really have no idea what's in the water. It could be good stuff, could be bad stuff. We're kind of doing a shot in the dark. So we do need to test our water to know those parameters. If you're wondering what tests you should be testing for and how often, we're going to refer you to our website where there is a testing chart for every kind of aquarium, whether it's freshwater planted, saltwater reef. And then you can find out based on your type of tank what test you should be doing and how often you should be doing them. Now when we're performing tests, the temptation that most people have is to be concerned with accuracy. Now what accuracy means is how close my test result is to that of the actual number. So one thing to understand with this is it's actually not quite as important as you might think. What's far more important is precision, which is what we'll talk about next. So let me give you an example of why accuracy can be not that important. So later in this video, we're going to do an alkalinity test. And at home, I keep my alkalinity right at about 10. Anywhere between 8 and 12 is okay. I keep it right at the middle at 10. Well, if I test once and I get 10, once and I get 12, once again and I get 8, they're still averaging out at 10, so in that sense, it was very accurate. If the true value is 10 and the average is 10, it was very accurate. But what the test was not was precise. So I would rather have a test that after testing 3 times, I got 9, 9, and 9. That's actually less accurate than the first test because the average was wrong, whereas the average of the first set of tests was correct. But it's more important that the test is the same every single time. In the first example, if I tested once at 10, I would have done nothing. If I tested again, it was too high, I may have stopped dosing elements, and then if I tested too low, I may have added elements when I shouldn't have. And this is why it's more important that the test is consistent than that the test is at the actual value of your water. And it's a little counterintuitive, but that's what we're going to look over. Now obviously we don't want it to be way off. If it was reading 1 when it should have been 10, that's a problem. We want reasonable amounts of both accuracy and precision. So what we're going to do now is we're going to do an actual water test, and this is going to help us review some of the things you can do to make sure that your tests are done with precision and they're repeatable every single time. Alright, so in order to show you guys some of the things you can do to make sure that your tests are precise and happen the same way every single time, we're going to go ahead and do an alkalinity test. We've chosen this test because it's the most common test that I do, and I use this API test kit to do so. This is a very simple test. It has one reagent along with a test file, and that's all we need to perform it. So the first thing to consider when you do this test, and with many other tests, is that you have a sample vial. And a lot of these sample vials will come with a line printed on it, just like this one here. And what you can do is you can dip this into the tank and try to get the water filled directly up to this line. But that's really not the best way to make sure that it's consistent every single time. It's much easier to use a syringe. So liquid medicine syringes like this one here are great for testing. We do have them on MarineAndReef.com and they're very affordable. So what I'm going to do is this here has tank water. I know there's 5 milliliters needed. So I'm going to fill my syringe to exactly 5 milliliters. Then I'm going to add this 5 milliliters of sample water to the vial. I'm just going to hold it to make sure it's steady. And we have 5 milliliters in there. Now you may notice this is actually slightly different than the line in the vial, but I personally trust this medicine syringe far more than the printed line. Now with this test kit in particular, the instructions are first to shake the bottle of reagent for 30 seconds. And it is pretty important that you do this for at least 30 seconds. Just going to be shaking back and forth, making sure that the solution in this is homogeneous. And once we've done it enough, we can add it in. The next thing that we're going to do, and I'll show you pretty soon once we're done shaking, is once we use this bottle, there's a dripper on the top, and you want to make sure that that dripper is oriented in the same direction. So shaking it enough, you can see the little drip nozzle on the top. And what a lot of people do is they'll hold this at an angle and then kind of tilt it in different ways. And what that means is the drops aren't consistent. Every time you change that angle, the drops are going to be a slightly different size. We want them to be a similar size. So the easiest way I found to do that is to completely invert the bottle and keep it vertical. And we're going to start adding our drops. Right. So with this test, it's very straightforward how it works. The API alkalinity test kit, you simply add drops. The solution will be blue, and once the color turns to yellow, you're complete, and you use the amount of drops you've added to find your number. I started with 6 because I know the tank usually stands around 8, so I can add most of them up front. And with the next few, I'm going to add them one at a time and wait for that color change. So again, the bottle completely vertical, add 1. I'm going to recap it. All right, we're still blue. And go do another one. And you want to repeat this process. And in general, with any test kit, so you got green, which means you're probably about 1 more. And we'll go to yellow. Looks like we're just starting to turn. So with this test kit, again, it's 1 drop per DKH of alkalinity. Because change seems about halfway to me, we're probably between 9 and 10 in alkalinity here. You know, we seem to have gotten the yellow color I was looking for. And that's pretty much it. The next thing we're going to show you is what to do when you're done. So we've just performed this test kit. I'm going to cap off the test solution and store it. Now that we have this water, we're going to want to dump it out. I have just a little dump container here. And we're going to want to clean this vial. We're going to want to clean this vial for multiple reasons. First off, if there's any of the leftover reagent that can affect other tests, but also if there's even leftover water, it can affect the tests. Now you can use tap water to rinse your vials, but tap water has lots of things in it that we're testing for, including little bits of calcium, of phosphate, of nitrate, and if you rinse it out with those solutions, it can skew your test results when those minerals get left behind. So in this case, this water here I was using was reverse osmosis water, and because that's purified water, it'll really help to make sure that the vial is rinsed clean and there's no contaminants left over. Then we can go ahead and store it for next time. All right, so that was a quick overview of what you can do to make sure that your tests are consistent and precise, that they get the same results every single time. Now we're going to move on to a few ways you can make sure that your test results are accurate or close to the true value of whatever parameter is in your aquarium. Now that we've discussed how to get precise test results, just mostly by standardizing how you test and doing it the exact same way each time, we're going to discuss how to get accurate test results, or test results that are close to the true value of your actual water. The first thing to consider when you're looking for accurate results is that a lot of times the most imprecise, most inaccurate part of the step is us as the human being. Sometimes you'll look at a test and the instructions will say, stop once the color turns orange, but maybe it doesn't look orange to you, it looks red to someone else, and when is the orange coming? Some even say once it turns from light blue to dark blue, but how dark is dark enough to be dark blue? And many times this judgment gives us a lot of error, or we can mess up the results. So in order to avoid that, one thing we can do is we can use a digital tester. So these are 2 of my favorite digital test kits. I have a Milwaukee pH pen, so digitally test for pH, and also another Milwaukee refractometer, which will test for your aquarium salinity digitally. And what's nice about these is when we use these test kits, we're not having to worry about colors or references. We simply press a button and we get a result. And this takes a lot of that human factor out, where different people can't interpret the test different ways, and we're already getting much, much closer to accuracy. While these pieces of equipment can be more expensive, they're also much easier to use, especially if you're colorblind or have poor eyesight, and they do have both accuracy and precision benefits because they take the human factor out of the equation. Another thing we can do, whether we're using a digital instrument like some of these or a test kit, is we can use reference solutions. So what a reference solution is it's a standard that was put together in a lab and guaranteed to be at a specific value. We have reference solutions for salinity, like this Two Little Fishies Accuracy, which is my favorite salinity reference solution. It's made using seawater and then tested in a lab and using the expensive lab grade equipment certified to be at a specific salinity. Then we can go ahead and test this, and if our test results match the given salinity that the manufacturer states, we know that the test is accurately reporting the results. Same thing with test packets like these little Milwaukee pH ones. These are guaranteed to be a very specific pH and are great to make sure that our kit is testing accurately. If you test this packet, test at 10.01, your test kit's pretty accurate because we know that the standard is 10.01. With a lot of the digital instruments, we can actually calibrate to these. So in other words, if I test this and I get 9.5 instead of 10, I can then adjust the instrument to match 10, and then going back to testing my water, ensuring that I'm getting an accurate result, knowing that the water is in line with what's actually happening. The last thing you can do if you're looking at all these test kits, you use some colorimetric test kits, digital test kits, and you're still worried about accuracy, is looking into an ICP test kit. So at Marine and Reef, we have these ICP test kits that are sold by icpanalysis.com. Purchase the test kit from us. You're going to take it home, put a sample of your aquarium water in, put a stamp on it, and mail it to the ICP lab. And there it will be professionally tested by a lab. And what's really nice about this is there's many parameters that are very, very difficult to test for. We can test for simple things like alkalinity, pH, salinity, but things like vanadium, strontium, molybdenum, these are things we can't even really test for. And even giving our very best to testing for these, having a professional lab test them is likely a lot more accurate. I try to do an ICP test every 6 months for my home tank, but it can also be a great tool if you're having mysterious problems. It's a way to get a baseline for if there's a problem in your water, or if you're looking for what can make things just that much better. If you're wondering, why don't my coral look as good as my buddies? Do an ICP test kit. It'll compare your water to natural seawater, and you may find that you're missing something or have too much of something, and that's what's causing your problems. You can also, in addition to getting the results with the ICP test kit, compare these results to your regular colorimetric or handheld digital instruments. If they're way off, there is some problem there that you want to fix. Maybe your digital instrument is running low on batteries or crusted up, or maybe your test kit has expired and it needs to be swapped out for a new one. But it's definitely a great tool for any aquarist to use. If you have more questions about test kits, additives, or other aquarium products, please visit the videos and education section at MarineAndReef.com. Thank you for your time.